Remember back when we first defined the 6 trigonometric functions, we used a right triangle, and all the trig functions were defined according to the parts of the right triangle. For example, sine of alpha was said to be the ratio of the opposite to the hypotenuse, cosine adjacent to the hypotenuse, and so forth. And because we had these 6 trig functions defined that way, we were able to, with ease, solve a lot of applications involving right triangles. Well, a lot of applications don't involve triangles. A lot of applications don't involve right triangles. A lot of applications involve oblique triangles, triangles without right angles. Now, of course, if you don't have a right angle, you don't have a hypotenuse, so you can't say opposite over hypotenuse. But we would still like to be able to use our trig functions even when we don't have a right angle in our triangle. So this is where the law of sines comes in. The law of sines gives us a method for dealing with problems that involve these oblique triangles. In particular, if we are given angle, angle, side, if we have a situation where we're given angle, angle, side, like this. So we're given this angle, and this side. Angle, side, angle. Angle, angle, and the included side. And then also side, side, angle. The law of sines gives us a method for finding the remaining parts. So if we're given, for example, this angle, and this side, we can find this angle, this side, and this side, and so forth. So it gives us a means for solving triangles that are not right triangles. Now what we want to do, rather than try to just memorize, okay, when I have angle, angle, side, angle, and side, side, angle, I use the law of sines. We don't want to just have the idea of, well, we're going to memorize these, and when we have this situation, we use the law of sines. Rather, we want to approach the law of sines from a standpoint of we're going to become familiar with the law of sines, and then when we're given information, it will be readily apparent, if we should use it. So I would focus on becoming familiar with the law of sines and not just try to memorize these things: angle, angle, side, angle, and side, side, angle. Now, let's see if we can investigate and find out what this law of sines is referring to. Here I've got an oblique triangle, and I'll go ahead and construct a height from the side AB up to the vertex C. And we want to take note that, of course, sine A is opposite over hypotenuse, h over b. Well, multiply both sides by b, and you have that the height is b sine A. Likewise, I could come over here to angle B. It's h over A. Multiply both sides by A, and you have h equal a sine B. Now, notice that b sine A and a sine B, they're both equal to h. Well, if that's true, I'll just equate them. And then notice I can divide by AB. And over here the B's will cancel, and over here the A's. Now, look what we've just discovered. We've discovered this amazing ratio, that this proportion. Sine A over A is equal to sine B over B. Now, that being the case, you can see how that if you know any three parts of this, you can find the other. For example, if you want to figure out what A is, uppercase A, and you know lowercase a, lowercase b, and uppercase B, you have now just an equation in one variable that you can solve. So you start to see how useful this law of sines can be. Now you notice there's no C involved in this. Angle C and lowercase c is not involved in this. So what we want to do is we want to involve these C's. Okay? We've got A's and the B's. Now let's look at the C's. So to do that, I construct a altitude from AC over to vertex B and proceed the same way as before. I notice that sine A is opposite over hypotenuse. This time the hypotenuse is C. Multiply both sides by C, and I get H is C sine A. Do the same thing for sine C. It's also H over A. Now, once again, notice we have these two things both equaling H. C sine A and A sine C. Equate them. Divide by AC. And there we have it. Now notice, sine uppercase A over A is equal to sine uppercase C over C. And this gives us, putting this together with what we did previously, this gives us the law of sines. Now, you notice that if this is true, then this also must be true. In other words, the reciprocals must be equal as well. So this is the law of sines. And you can see how useful this will be to find missing parts. If you know any three of these parts, if you know any three, you can find the fourth one. Now let's look at an angle side side problem. Okay, I'll draw out what we've been given here. We're given this information, an angle, another angle, see, and then a side. Now the easiest thing for us to find in solving this triangle is A, because the sum of the angles of a triangle is 180 degrees. So I just take 180 minus 102 plus 28, and that gives me 50. So angle A is 50. So now we have all the angles. What we have left to do in solving this triangle is to find side A and side C. Now, using the law of sines, I know that A over the sine of 50 is equal to 27 over the sine of 28, is using the law of sines. Multiply both sides by the sine of 50 and do the multiplication, you get 44.056. So we found A. Now the only thing left for us to find is C. Okay? So here we've got C over sine of 102 equals 27 over sine of 28. Looks just like the previous problem, except now we're dealing with the lowercase c. And we find that lowercase c is 56.255. So the law of sines is quite useful to us. Notice how easy this is. Just being aware of these ratios and these proportions. Help us to tackle these oblique triangles. Okay, now let's look at angle side angle. Here we've got the C is 100, the B is 26, and the A is 45. So now the side that we're given is included. And still we can find the side A, the angle A as before. Now the only thing left to find, the only two things are B and C. So we set up B over sine 26. Okay. Notice B over the sine of the opposite angle equals 45 over the sine of its opposite angle, and we find 24.384. 24.384. Now, the same procedure for side C. And we get 54.778. So you see, these two problems, the previous one and this one, work the same way. Just the information that we were given was a little bit different. We were given the included side this time. Now, we want to look at this third situation here, the side-side angle. And this is known as the ambiguous case. The ambiguous case can be a little tricky because with the ambiguous case, it's possible that the given information does not correspond to a particular triangle. In other words, you may have no solution. There may be no triangle that fits the information that you're given. On the other hand, you may have two triangles that will work as solutions, or you may have one solution. So it's ambiguous. So you need to be aware of this. If you're ever given side, side, and angle, be careful because you could have any three of these, any one of these three. So let's look at the case where you have no solution. How could that be that you would have no solution? Well, consider this. Let's suppose that you were given that a is 2, lowercase a, lowercase b is 15, and the angle is 80. Well, look at this. Here you have an angle of 80. B is 15, so you go way up here, and then A is 2. A is not long enough to reach down and complete the triangle. So this is a situation where you have no solution. Now, you don't really have to worry when you're given this information whether or not it has no solution. If you just start working the problem, you'll soon find out there's no solution. Here's how. Let's suppose you just blindly, well, first of all, notice that the height in this situation, your height here is less than A. So you can just look at this and tell, okay, there could be no solution. Now look at this. If you just start working, you have sine B over 15, okay? Just using your given information equals sine 80 over 2. Go ahead and multiply both sides by 15. Now look what you have. You have sine B is equal to 7.386. That's impossible. Sine cannot equal anything other than anything outside the interval -1 to 1 inclusive. Sine B can be -1, sine B can be 1, and anything in between, but it cannot be anything outside that interval. So to say that sine B is equal to 7.386 is not a possibility. So you immediately recognize, okay, this triangle has no solution. Okay, now let's look at the two-solution scenario. Now here's the thing. Notice that when you're given side, side, and angle, the angle that you're given needs to be acute for you to have the possibility of having two solutions. So that's the situation here, but it's not enough. In other words, just because you have an acute angle given does not mean you have two solutions. But it's a situation it's a condition that has to be met. And that's a condition that's met here. Notice the angle that you're given is 18 degrees. Now, here's one possible triangle. Notice that the A of 5 goes out here. Notice I wasn't told how long side C was. So I just took the A and extended it out here. Now here's another scenario. Instead of the A going this direction, it comes back this way. So side C is shorter than it is over here. So this is an example where you have two triangles that are possibilities for this, for the solution, for this given information. Now let's take a look here. I'm going to drop an altitude or height down for both of these. And we want to take notice of some things here. First of all, notice that the height is less than A on this triangle. And that has to be, right? Because A is the hypotenuse that's formed when I construct this height. So obviously H has to be less than A there. And over here, H is less than B. Because notice that B is the hypotenuse of this triangle. Okay? A right triangle is formed here, and B is the hypotenuse. So B has to be longer than H. Now, both of these have to be true. H has to be less than A, and H has to be less than B for you to have two solutions. Now let's take a look here. Notice this. Obviously, sine A is equal to H over B because a little right triangle is formed here, and a right triangle is formed here, H over B. Multiply both sides by B, and you get that H equals B sine A. So look, here's what we want to conclude from this. What we're trying to do is devise a little test that you can use to determine if there are two solutions. If there's one solution or zero solutions, there's not really a lot to worry about. With zero solutions, you soon encounter a situation that, like, you'll try to take the sign of a number bigger than 1. You know right away there's no solution. If there's one solution, or two solutions is the question. So here's what's going to determine if there's one or two solutions. Notice, H is equal to B sine A. Now, here's what happens. For two solutions to exist, it is necessary and sufficient that this happen. H, B sine A, is less than A and is less than B. That has to be true for you to have two solutions. And if you have two solutions, that is true. So that's the way you can test. If you're given this information and you want to find out, does it have two solutions? Plug in your B, your uppercase A, and see if that's less than the lowercase a, and see if that's less than the lowercase b. If that's true, then you have two solutions. Now, we really didn't talk about the fact that A has to be less than B. We just talked about that B sine A has to be less than A and it has to be less than B. But you can see clearly from these drawings that, yeah, A would have to be less than B. If you look at this, consider if A were greater than B. Well, if A were greater than B, then you could not do what I did here. I drew this triangle, extended A this way. And then I turned A back and made this triangle. If A had been greater than B, I could not have done that. So that's one way that you can see that, yeah, A has to be less than B. Now, let's look at this same problem continued. This time we'll go ahead and find solutions. Okay, here are our two triangles. And first of all, we do the test. B sine A. Well, here's B sine A. 15 sine 18, and that's 4.635. Sure enough, that is less than 5, and that's less than 15. So that tells us there are two solutions. So we keep that in mind, and we proceed just to find the first solution. So here we go. Sine B over 15 equals sine 18 over 5. Okay, so looks like we're solving for B first here. Sine B over its opposite side equals sine 18 over its opposite side. Multiply both sides by 15. And you get this, which is 3 sine 18. So sine B equals 3 sine 18. And then inverse B is equal to the inverse of that would be 67.980. So that's angle B. Now, angle C. Once we know A and B, C is easy to find. It's just 180 minus the sum of the previous two angles. And you get 92.02 degrees. Now I believe all that we have left to find is the lowercase c, using the law of sine. C over sine of 94.02 equals 5 over sine 18. Multiply both sides by sine of 94.02, and you get your result. 16.141. Okay, now that is the solution for this triangle. Now we want to go to the next triangle. Now, we want to start here. We want to recognize that on the previous problem we found angle B by taking the inverse sine of 3 sine 18 degrees, and we found it to be 67.980. But now, look, when you take the inverse sine, it's going to give you an angle in quadrant 1. However, we know that this point 927, that's the value for sine. In other words, this is saying what angle will give you a sine of 0.927? Well, 67.980. But that's in quadrant 1. Remember, that 67.980 corresponds to an angle in quadrant 2. The sine of that angle is also 0.927. So what we want to do is utilize that fact and say, well, look, this is how we find the other angle. We know that the sine of 180 minus 67.980, it's also 0.927. Therefore, we say that this B prime over here can be found by just taking 180 minus 67.980, and we get 112.02. In other words, that's how we find the other angle for the other triangle. By recognizing, yeah, this inverse sine will give us the first quadrant. But there is a second quadrant angle that corresponds to it as well, and that will be this B prime. Sometimes that's something you have to think about a little bit. Now, so we've got B prime. Now, C prime, we take 180 minus the other two angles that we know, and we get 49.98. Now, I guess the only thing left to find is C prime. C prime over sine of 49.98 is equal to 5 over sine of 18. Okay, and that equals, when we do our algebra, we get 12.391. And I believe we've solved the second triangle. Now let's look at a summary here. Of course, we have the law of sines. And the law of sines is typically used when you have angle, angle, side, angle, side, angle, and side, side, angle. Now, when we have side, side, angle, we can have no solutions, one solutions, or two solutions. And the way you determine if you have two solutions is by calculating B sine A, seeing if that's less than A is less than B. That's if you are given, if you're given A, uppercase A, lowercase a, and lowercase b. You might have to adapt the formula if you're given, angles named something different. It won't always be B sine uppercase A less than A and less than B. But notice what this is saying. This is saying this uppercase A and this lowercase a is the opposite side. Okay. And then you have the other side given, B.